All right, we have reached the final and third logarithmic property, which is called the logarithmic power property, because it requires us to put something into a power. All right, and so this is the equation right here. We have some number or variable times log base b of a. That's the same thing as log base b of a raised to the c. Now that might seem really strange, but let me give you an example and see if we can make sense of this. Again, I'll use orange because orange is the new black. All right, so let's go ahead and do this. Let's say I got 2 times log base 3 of 9. Okay, well, according to our formula, that means this is the same thing as log base 3 of 9. Well, the 2 is going to apparently go on the exponent, right? The c is going on the exponent to get a raised to the c power. So this is going to be, I said this was a 9, okay? And this is going to be 9 squared. Well, does that make sense? Well, let's actually try it out and see if this actually works or not. So this right here, let's go ahead and change colors now. This right here is telling us, all right, 3 raised to what power equals 9? Well, that's 2, right? So we're going to get 2 times 2, which is equal to 4. Well, let's figure out this thing better equal 4. So first of all, this right here is log base 3 of 81. So this is saying 3 raised to what power is 81? Well, this better be 4. So let's pull out the calculator and let's verify this thing. 3 raised to the 4th. 81. Perfect. So we know that's equal to 81. All right. Well, not convinced still. Let's try one more. Let's say 3 times log base 4, and let's use 16. And according to this equation, this is going to be log base 4 of 16. Well, you bring the 3 when it's multiplying to the log and put it on the exponent, so to the third power. Okay, well, what is this saying right here? This is saying 4 raised to what power is 16? Well, that's 2, so this is 3 times 2, which is equal to 6. Well, let's figure out if this is actually true. So first of all, what the heck is 16 raised to the third? 16 raised to the third is 4,096. All right, so we have log of base 4 of 4,096. What is that saying? That's saying 4 raised to what power is equal to 4,096. All right. Seems strange, but it better be 6. It better be 6. So 4,096. My bad. Let's go back. 4 raised to the 6, and we get 4,096. Well, would you look at that? That is true. And that's how we know this formula works, and it works for anything. So let's go ahead and get some practice with this thing, huh? So let's try, let's say we have x times log base 7, and we have 12. Well, let's rewrite that. Well, it doesn't matter if it's an x or a number. It's still the same. You can put the x on the exponent. So this is going to be log base 7 of 12 to the x. Okay. All right, let's try another one. Let's say I have 3 times log base 4 of xy plus log base 4 of x. Well, when we go to do a problem like this, we have to be a little careful. I want to simplify this. Well, there's this 3 being multiplied here, so I can't just combine these inputs here. I have to figure out what to do with the 3. Well, we're going to use our property we just learned. Let's put the 3 back on the exponent. So it's going to be log base 4, and we're going to get xy all raised to the third power plus log base 4 of x, and we have this equal to. Okay, we put that back. Now you have to be careful, because when you put the 3 back to the exponent, it's not just being applied to the y. You're not just going to put a 3 here, but it's also on the x. All right, you have to do to both of them. That's why I put parentheses first. Now I know that these are like 1s here, so 1 times 3 is 3, y times 1 is 3, so I know this is log base 4 of x to the third times y to the third plus log base 4 of x. Now that I have this fully simplified and everything is put inside of this log, now I can combine it because I'm going to multiply this with this, and I'm going to get log base 4 x to the third times y to the third times x. And this whole thing becomes log base 4 of x to the fourth times y to the third, because there's 4 x's being multiplied. You see a little bit of a challenge problem here. Okay, let's try just a few more that I really enjoy. Let's say we have 2 times log base 3 of the square root of x. Well, first of all, what's the invisible number in front of the square root symbol? Well, it's a 2. So this is actually 2 times log base 3 of x to the 1/2. Now, using my property, I can bring this up, and I'm going to get log base 3 of x to the 1/2 times 2 on the exponent. Well, what's 2 times 1/2? Well, they cancel out and you're left with 1. So this is just log base 3 of x. Pretty dang radical. All right, one last example problem. What the heck? I'll use Brown. Let's say we have 4 times log base 11 of the cubic root of a. Well, first of all, let's rewrite that. That's 4 times log base 11 of a raised to the 1/3. Okay, now I go and put this back on top on the exponent here, and I'm going to get log base 11 of a to the 1/3 times 4. Well, notice the 4 and the 1 are on top. What's 1 times 4 is 4. So we're just going to get log base 11 of a to the 4/3. Pretty fancy. That's how we apply this property. Hopefully that makes sense. I went through a few example problems, but I know some of these you're just going to have to get practice. In part 2, we'll get some more and we'll go backwards. All right, you take it easy and enjoy yourself.